As an extension of multiplying polynomials and using the FOIL method, we're going to talk about special products today. The first special product that we're going to discuss is called the square of sums. Now, you can see that I only have one parenthesis here, 3x plus 5, but it is raised to the second power. And what we've learned about exponents is that when I have a second power, that means my base, whatever my base is, I have two copies of that. So in this case, I actually have two copies of 3x plus 5 times 3x plus 5. Now that I have those two, I can go in and use my process of multiplying two binomials together by FOILing it out. So I go through FOIL. 3x times 3x will give us 9x squared, my first terms. My outside terms, my outer terms, 3x times 5 gives us plus 15x. On the inner terms, 5 times 3x will give us another positive 15x. And my last terms, 5 times 5, will give us plus 25. After we FOIL, we always look to combine like terms. I look in the middle. I have 15x plus 15x. So that'll give us a final answer of 9x squared plus 30x plus 25. So the big takeaway out of this is that when you see a one parenthesis raised to a second power, we need to make sure that we write it out twice and go through the FOIL process. So let's try another sum of squares. This time it's got a second variable in there. Now the y might throw you off, but it's still the same idea. So since I have a second power, I'll write out each parenthesis twice, and I'll go through the process of FOIL. So 3x times 3x for the first terms still gives us 9x squared. The outer terms, 3x times a 4y. Now, since the letters are different, I can't add the exponents, so I will multiply 3 and 4 to get 12, but x times y will just remain xy. The inner terms, 4y times a positive 3x, gives us another plus 12xy. My last terms, 4y times 4y, 4 times 4 is 16, y times y will give us y squared. And again, I have to combine like terms, so I look in the middle. I see I have xy, and I have another term that has xy. So those are my like terms. I'm going to combine those together. 12 plus 12 will give us 24, and I have a final answer, 9x squared plus 24xy plus 16y squared. So again, that's the sum of squares, or the square of sums. What about a square of differences? So again, I have one parenthesis, but because of the exponent, I will write that parenthesis out 2 times. And I once again will go through the FOIL process. Take my first terms, 2x squared. 2x squared will give us 2x times 2x will give us 4x squared. My outer terms, 2x times negative 5y, will give us negative 10xy. Inner terms, negative 5y times 2x gives us another minus 10xy. Last terms, now I've got a negative times a negative, so that will give us a positive. 5 times 5 is 25, and y times y will give us y squared. Again, I look in the middle. I have like terms, a negative 10xy, another term of negative 10xy. Together, those will give us a negative 20xy, so a final answer of 4x squared minus 20xy plus 25y squared. So there's your square of differences. Now let's try an application of this. Each edge of a cube of an aluminum is 4 centimeters less than the edge of a copper cube. Write an equation to model the surface area of the aluminum cube. Now I'm going to give you two cubes here. There's the copper cube, bigger than the aluminum cube. We're going to go ahead and let the letter C represent the length of each side of a copper cube, so that the side of the aluminum cube is 4 less than that, so I take away 4 from C, so that'll be C minus 4. The next thing that we're going to need is, how do you find the surface area of a cube? Well, here's the formula for the surface area of a cube. SA, standing for the surface area, is 6 times the side length squared. Well, our side length for the aluminum cube is C minus 4. So where I see the S, I am going to substitute in the C minus 4. Now the next thing you want to think about is PEMDAS, the order of operations. If you remember in the order of operations, exponents come before multiplying. So I have to apply the exponent in there first. So the c minus 4, since I have the second power, I have 2 copies of that parenthesis. And I'll go through foiling the parentheses before I do anything with that 6. So c times c will give us c squared. C times negative 4 gives us a negative 4c. Enter negative 4 times c gives us another negative 4c. And the last two terms, negative 4 times negative 4, will give us the positive 16. I go in, combine my like terms in the middle. Got 6 times the c squared minus 8c plus 16. And then finally, I can do the multiplication where I distribute the 6. So I get a final answer of 6c squared minus 48c plus 96. This is the polynomial that represents the surface area for the aluminum cube. The last thing that we'll discuss is the product of a sum and a difference. If you look at my first parenthesis and the second parenthesis, the terms look pretty similar. The only difference that I have is that the first parenthesis has the sum, the plus sign. The second parenthesis has a difference, the negative sign. Let's see what happens here when I FOIL this out. First, 2x squared times 2x squared will give us 4x to the fourth. Remember that whenever we have a product of powers, we add the exponents to the like terms. Outside, 2x squared times a negative 3 will give us negative 6x squared. Inner, 3 times 2x squared will give us positive 6x squared. And last, 3 times negative 3 will give us negative 9. After we FOIL, we've always combined our like terms. So if I look in the middle, negative 6x squared plus 6x squared, negative 6 and positive 6 are going to cancel each other out. And I will no longer have 3 terms in my final answer. I will have 2. So the final answer here is 4x to the fourth minus 9. So the takeaway out of this is that when you have a product of sums and a difference that are the same, but different signs, your middle terms are always going to cancel out and you're going to have 2 terms in your final answer. So these are some special products that we'll go through. We have the square of a sum, the square of a difference, and then finally the product of a sum and a difference.